Hello everybody. In this video we're going to solve AP Precalculus 2025 free response questions. This is free response problem number 1. Part A, I is asking the value of h of 1. H function is defined as G composition f. So we can rewrite as h of 1 as G of f of 1. From the table, f of 1 value is equal to 1.75. So h of 1 turns into G of 1.75. And all we have to do is just plug in this input into our G function here. This year, students had access to use Desmos online graphing calculator. So let me show you how you could do on Desmos. You could go to type just a G function as it is given. Negative 0.167 x to the third plus x to the second minus 1.834. Once you have typed your G function, just whatever value you need on the G function, you can just type in. So G of 1.75 is equal to 0.3334. 0.3334. If you didn't know this feature of Desmos program, you could use your TI-84 by just plugging x value as 1.75. So negative 0.167. Instead of x, type 1.75 raised to the third power plus, again, instead of x, 1.75 raised to the second power minus 1.834 and just enter. You get exactly the same value. II part is asking f inverse of 3.5. F inverse of 3.5 is equal to 0. Just checking the table. The input and output of the inverse and regular function is equal to each other. The input of f function is equal to output of the f inverse function. So from the table, output is 3.5. That means that's going to be the input of the f inverse, which is going to give you 0. BI is asking find all values of x for which g of x is equal to 0. So that is the other way to ask for what the x-intercepts are. So just go to your Desmos calculator. We have already graphed it. All you have to do is just check the x-intercepts. So x1 is equal to negative 1.2332. We have 3 x-intercepts. x2 is, go to second x-intercept, 1.5780, and the last x-intercept, let's get rid of those first two, 5.6431. On TI-84, you could again graph it and check the x-intercepts. Type your G function on y1. On y2, type just 0. Y equals to 0 is the x-axis. So we have two graphs that we can check the intercepts. So graph it. Second, trace. Number 5, which is intersection. So you're very close to third x-intercept. Just say enter 3 times. And then you get 5.6431 as we got here. Second intercept, we have to click on second, trace, number 5, which is intersect. Manually come very close to second x-intercept. And then type 3 times enter. enter, enter, enter. 1.5780 as we got here on Desmos. And the third x-intercept, again second trace, 5, which is x-intercept. Go very close to x-intercept you're looking for, and then enter 3 times. 1, 2, 3. You get 1.22, 1.2332 as we got here, and it's negative. Alright, let's go to BII. So determine the end behaviors of the function. We already graphed the function on Desmos that you can see. It is behaving as negative x to the third because leading coefficient is 3 and it's negative. So here you can see as x is going to negative infinity, g function is going to positive infinity. As x goes to positive infinity, g function is going to negative infinity. We have to express it in limit notation. Limit, as x is approaching to negative infinity, g of x is approaching to positive infinity. And limit, as x is approaching to positive infinity, g function is approaching to negative infinity. Part C is asking how we could model this function f. So f function is given in the table. As we can see that x input values are increasing in the equal intervals linearly. Output values are decreasing exponentially because decaying 50%, 50%, as you realize that each next output is half of the previous one. So we could model it at exponential. And the reason is, as we said, as input values are increasing in the equal interval, the output values are decreasing exponentially, which is 50%. Let me write it. As input values are increasing over equal interval, which is linearly, our output values are decreasing exponentially, which is decreasing 50%. Or you could say that output values are proportionally decreasing on the same increment with the same rate. So anything equal to this expression gets the full credit. Or this is just by definition of the exponential function. Thank you for watching FRQ1.